Hello and welcome everybody to our presentation on managing OpenTelemetry using Cribl Edge as a deployment tool. In today's presentation, we will be going over the work that us at NETbuilder completed for a large telecommunications company, and we will discuss what they hope to achieve, the issues they ran into, and how we designed and implemented a solution to meet their needs through the following sections. And just a heads up, our colleagues at NETbuilder have slipped in a few jokes into this presentation, so if you think they're funny, you can thank us, but if not, blame them. Starting off with some introductions, I'm Greer, an observability consultant from NETbuilder, and I currently work out of the UK's Brighton office. A fun fact about me is that I'm an avid 3D printer outside of work, and I'm currently working on making Spartan helmets from the video game series Halo.
And I'm Moran, a principal consultant from NETbuilder, also based out of the UK, and I'm an avid home lab builder. We also want to shout out Ash Bending on here, who couldn't make it to CribbleCon, but helped with the engagement and putting this presentation together. So we're excited to walk you through a project that began as a standard request, but evolved into a fascinating case study on the flexibility of Cribl Edge. It started when we were approached by a global telecommunications leader for what we thought would be a simple Cribl stream and edge installation. The project criteria was very clear. They needed to collect data from 17 different endpoints, devices, and applications, and they wanted to reduce their number of management platforms to just one, if possible. And this seemed like an easy solution using Cribl, with the leader as the central management platform for the edge node. However, as a subtle foreshadowing at the end that suggests, a unique challenge was awaiting for us. So before delving into the technical details, let's quickly cover the why behind this project. This client had two main business goals driving this change. Firstly, they were focused on saving money on software, like most clients, and this plan was to reduce the number of different log collection tools they were using to save on license costs. They also wanted to leverage Cribl to drop unnecessary events at the edge and reduce the size of data sent to their systems of analysis, again, like most businesses. So secondly, they wanted to streamline their workflows by using a single platform to manage log collection, which would greatly reduce platform maintenance overhead, freeing up their teams to focus on other important items.
Thanks, Dan. So with these business goals in mind, we then had to sit down with each of the 17 individual teams. Each of these teams were responsible for a different type of technology, such as endpoints, devices, and applications that we would need to collect logs from. Therefore, these teams each came with their own needs that needed to be covered by our implementation. An additional team was also introduced to us, being the infrastructure team. They were responsible for the success of the product, and therefore we were working very closely with them. Out of all of these different teams, they were all pretty straightforward in their needs. Just deploy Edge to collect telemetry X and point it to Cribl Stream. And as all deployments, things were going swimmingly until the client got involved, or in this case, the application team. This application team wanted to collect telemetry from all of their deployed apps in Kubernetes, and they wanted to use this telemetry for debugging. These apps deployed in Kubernetes were deployed in Kubernetes with multiple apps deployed across the entire company's infrastructure. They're currently using OpenTelemetry to collect this data, as they could use OTel's instrumentation libraries to get custom traces. And they were not too happy with the idea of moving to Cribl Edge and having to leave these instrumentation libraries and all of the effort put in there behind. However, we did discover they were having issues with managing this instrumentation through through OTel. This is as they didn't have access to the same deployment tools as the infrastructure team had. And they didn't want to keep going to the infrastructure team every time they wanted to update their configurations.
So that, as Chris mentioned, this is where we hit the real span in the works. The requirement to manage OpenTelemetry meant that we would likely need a second management platform, which went directly against the infrastructure team's primary goal of consolidating everything into one tool. Additionally, at the time, OpAmp, which some of you may have heard of, which is OTel's relatively new and native management plane, was in alpha state at the time, and therefore couldn't be considered a mature enough option at the time, and most likely even to this day. Additionally, we had the classic conflict between two teams. So we had the infrastructure team which argued that Cribl Edge could already gather everything needed from the environment using its native Kubernetes events and metric sources. But then we had also the application team, and they needed to keep their program-specific instrumentation libraries as generic metrics weren't enough for their deep debugging needs. And this stalemate left us with the central question, which would define the entire project, and that is, can we manage OTel through Cribl Edge? So faced with that central question, our team investigated a few possible solutions to see how we could meet the requirements of both the infrastructure and application teams. First, we considered just using a separate UI for managing OTel, but this was immediately discarded. It directly violated the single platform goal, that the business set out. The second option was to configure OTel to be extremely verbose and then use Cribl's processing power to aggressively drop any of the unwanted telemetry. Not efficient, could waste resources if we had to drop it in stream, and it just wasn't an option. We also thought about using an external web server to host the OTel config files, but that ended up just being, again, not an option because it would add another piece of infrastructure to maintain, which wasn't available to us. So after weighing the options, we found a more elegant and integrated solution. We decided to host the OTel configuration directly within a Cribl pack, and this allowed us to leverage the Cribl UI and its deployment mechanism to manage a completely separate agent, that being the OTel, keeping everything under the single pane of glass in the leader. So I'll hand back over to Chris, who will kick off our demo.
Thanks, Dan. So for our intended solution to be successful, we would need to update and deploy OTel configurations across all the client's hosts using only Cribl Edge. Doing so would meet the infrastructure team's requirement of a singular management platform, while still giving the application team the granular, instrumented traces they're grown accustomed to. In doing so, we'd also demonstrate that Edge can be used not just for collection, but also as a deployment tool. And here on the screen behind me, you can see an overview of our final solution that hinges on executing a simple script to update the OTel config file. However, the execution of this script would need to be automated.
So as Chris was saying, in order to operate our intended solution, we had to ask ourselves how such a solution could be automated with Cribl. And to do so, we would need to execute a command on all the hosts and to deploy config changes over a given schedule. And luckily, Cribl Edge had its exec source, which would run at a set interval. And although this is what was used in the final version, we could have also used the script source in retrospect, but that would have had some additional security considerations, as some of you may be aware, and it would require some additional permissions, which we weren't privy to at the time. Quick joke, I'm so sorry. Why don't Cribl engineers get stressed about noisy logs? Because they know how to filter out the drama. Sorry.
Let's take a look at how the script runs at a high level across its 8 key steps. First, we ensure we can authenticate with both Cribl and Kubernetes before we convert the config file saved in the pack's lookup directory to a YAML file. We can then replace the file in the OTel directory with this YAML config for a checksum test if any changes are present to determine if it's necessary to restart that OTel collector. Dan will now begin explaining these steps in further detail.
Yeah, so when we started implementing our solution, the same as any Edge deployment, we obviously deployed the Edge nodes to all the Kubernetes clusters and hosts. It should be noted that as a standard, only one Edge node is required per host or cluster, or node, depending on how you're configuring it, which helped to keep the management overhead down. Again, sorry, quick joke. Why did the log move out to the suburbs? Because Cribl Edge told it to process closer to home. Which is also practical advice.
Due to the application team already utilizing these clusters, they found to already have OpenTelemetry deployed on them as a Kubernetes node. So this made our life easier, as it meant we didn't have to go through and deploy OpenTelemetry agents on them as well.
The other application nodes in these clusters had been instrumented using the OpenTelemetry libraries mentioned previously. These would allow for unique metrics and traces to be collected from these nodes.
So how will we start deploying a config to these nodes? Firstly, on our local machine, we create the OTel YAML config file, as you would with any other implementation. This allows us to run some local tests to ensure the configuration operates as expected. Once this is confirmed, we can begin pushing it to these Kubernetes nodes. But how do we go about this?
So the file that we just developed locally is uploaded as a lookup in our Cribl pack. And yes, it's technically not a valid lookup, but thankfully, Cribl in our case still allowed us to upload the file. And the key thing is that we now have the means to deploy the file via the pack, via the UI.
Thanks, Dan. So as you just alluded to with the configuration of the pack, we can then push the pack to our edge nodes in the Kubernetes fleet using Cribl's commit and deploy mechanism. One upside of using this mechanism as well is if we ever needed to reverse any changes because there were unknown issues with that configuration, we could just use the built-in GitOps to roll back those changes.
And once deployed, we use the exec source to run the script. And when this occurs, the first thing that happens is the edited CSV file is converted into a YAML file, which can be used to configure OTel.
The new YAML file is then copied from the pack to the OTel directory, effectively overwriting that previous configuration that resided there. This allows our new working configuration to be published.
The file's checksum is then calculated by the script and compared to the expected value. And then due to the checksum being different, the OTel node restarts. And this allows the new configuration to take effect within OTel.
And with this configuration deployed and the nodes restarted, the new telemetry should now be forwarding to Cribl Stream. And this completes the walkthrough of our implemented solution. And just another quick joke. Doctor, I feel like a goat.
How long have you felt like that?
Since I was a kid. Now we've spoken about how the solution operates in theory, let's show you it in practice. First off, let's show that there is currently no data flowing into Cribl Stream. We can do this by navigating to the live data tab on our OpenTelemetry source and running a capture. As this capture runs, we can see by default we have no data coming into Stream from our edge nodes.
And then before progressing further, we can show you the OTel YAML config residing in Cribl. So to do that, we just navigate to knowledge and view the lookup. And we can see the YAML file in there where you typically configure CSV lookup. And we can see in that configuration, there's a wrong URL, which we purposely broke for the demo so that there's no data flowing through at this point.
Now let's show you our Cribl Edge fleet configuration. We can do this by navigating to Cribl Edge and selecting Confleet. And heading to the correct section of our fleet, we can see the exec source where the script is stored. Clicking Configure on this exec source, you can see the script stored as a single line. And you can also see here the interval is currently set to 60 seconds. But this could be decreased to speed up how often changes are checked for.
And then in this quick video snippet, we are on the host where our config is going to be deployed. Navigating to the OTel directory on the host, we can open the YAML file and we can confirm that that broken URL that I showed you earlier is there as well. And we also have another file which has the checksum that we also discussed previously to check whether OTel needs to be restarted.
Lastly, checking the debug output on one of the hosts, we can see logs confirming issues exporting to the current URL. Now, instead of going through hundreds of servers correcting this mistake, let's use Edge as a deployment tool to resolve this issue.
Thanks, Chris. So now we'll run through the process of updating the configuration from start to finish. So we'll head back to the pack, knowledge, and we'll find the incorrect URL and update it with the correct one, making sure we click save after we've done that. Then after that, we've deployed the change. We're obviously skipping a few steps here. We look to our host and we'll look to see if it's restarting. This can take a bit of time as the change has to be pushed from the leader to the edge nodes and the script then needs to be executed. And then once it's restarted, just there, we can check the checksum file to see this value has changed, with this being what caused the restart. And then moving over to the configuration file, we can see that the values here now represent those that we have pasted previously in the lookup editor in Cribl. And then, if it all works, which we know it did because it's our recorded demo, we should see some debug logs flowing there on the right with the correct URL. And then on the left, in just a second, we'll see the same live capture if we go to the OTel source as well. There we are. So the logs are now matching from the left side and the right side. So that brings us to the end of our really quick demo, just showing you the possibilities of what we can do based on what we did at the client.
So some practical tips we learned from this engagement include making sure you give the right permissions to the Linux Cribl user, as it needs to be able to read, write, and delete files and directories. Another tip we learned is rather than using the exec source like we have in this demo, it is better to enable scripts on those edge nodes, though that does require more work. And lastly, decide on what needs to be instrumented in the applications as early as possible, as this means less configuration changes down the line. Another quick joke, why is it hard to carry on a conversation with a goat? Because they're always butting in. Some positive impacts we observed from this implementation as well. The client now has a single centralized collection management that allows the infrastructure team to manage everything through Cribl, including the telemetry collection of both edge and OTel agents. Secondly, the client has consolidated their collection agents with the infrastructure team's workflow being streamlined, as they can now spend less time managing all these different technologies and more time dealing with high priority issues. Lastly, the client has gained some flexibility, with the application team still getting the traces that they require in the format that they requested, but with the ability to alter that format through Edge as a deployment tool.
And this solution was incorporated into the then ongoing stream deployment we were doing at the time, with Cribl Edge forwarding telemetry to Cribl Stream using the Cribl HTTP destination as its best practice, and allowing collected telemetry to use Cribl Stream tools. Cribl Edge also only required a single node per host, which lowered the required management overhead. And once the data was in stream, the data was pre-processed for routing purposes, with packs made to reduce the size of the data before sending it downstream. And we also, of course, used some available packs to us from the dispensary for formatting common sources. And once we had all this telemetry flowing from Edge into Cribl Stream, we were able to unlock even more value and directly address the client's business goals. So when we first deployed the solution, the client was ingesting about 1.5 terabytes of data per day. And fast forward 7 months from that point, that volume has grown exponentially. That client now ingests 20 terabytes a day, but thanks to Cribl Stream, they export about 13 terabytes to their respective observability tools with room for much more reduction. And that means we are dropping an average of 7 terabytes a day on average, which is about 35%. And yeah, this proved the platform's value at scale very quickly. It was considered a success, and we swiftly moved on to phase 2 to get some more reductions. So to wrap things up, what are the key takeaways from this project?
First, we learned that Cribl Edge is even more powerful and flexible than we initially anticipated. We went in thinking of it simply as a data collector, but we came out seeing its power as a deployment tool that can consolidate a mix of collectors in diverse environments.
Secondly, this project highlighted some incredibly helpful capabilities for modern agent management. This ability to execute scripts remotely was the cornerstone of our solution, allowing us to deploy configs remotely and manage OTel without a separate tool.
And finally, this all proves that streamlined data management in today's complex environments requires agile tools. Edge has demonstrated that as a flexible agent for modern data collection, allowed us to solve a unique problem while sticking to our client's core principles. And although we only spoke about OTel today and deploying OTel through Cribl Edge, its use as a deployment tool and the ability to run any scripts means that anything can be deployed using this. And that brings us to the end of our presentation. We'd like to thank you all for watching, and if you have any questions, we're going to hang around down here, or feel free to contact us via emails or LinkedIn on screen now.
Thank you.